right, the purpose or the focus in co-requisite material lesson 3 is to start thinking a little bit about solving equations and then evaluating z-scores, something that comes up a lot in statistics, not only as z-scores, but also test statistics once we get into hypothesis testing. So, to kind of jog your memory on solving equations, remember if we do something to one side, we must do it to the other. So, in this case, I see this -3 in the denominator. I'd like to be able to get rid of that, so I'm going to multiply both sides by -3. So, part of being successful at solving equations to have a little bit going on is just being organized. So, I very carefully multiplied the left side by -3, and I've very carefully written out the right side as being multiplied by -3. Make sure that -3 is in parentheses, because if you just write -5x times -3, you may have the intent of multiplying those, but that's not what this expression is saying. This is saying -5x minus 3, as opposed to that saying we're taking -5x times -3. So just writing out very carefully. I know because this is common because I've helped my daughters work similar problems. So anyway, multiplying this out, the -3 would cancel out. So I have -3 times the quantity 4 minus x. Notice I write that very carefully. And then on the right-hand side, I get -5 times -3, which is positive 15x. So distribute the -3. -3 times 4 is -12. -3 times -x is positive 3x. And I have 15x on the right side. Next thing I would do, I could do this mentally. Just subtract 3x from both sides. If you can't do it mentally, no big deal. Just write -3x and -3x. So -3x minus 3x is 0. 15x minus 3x is 12x. -12, still hanging around. Divide both sides by 12. So 12 divided by 12 is 1. -12 divided by 12 is -1. So -1 equal x is the same thing as x equal -1. Now, in evaluating z-scores, these are pretty simple. The only trick is when we enter the numbers in, we substitute x equal 108 in for x, and mu is 100, substitute that. Sigma is 14, substitute that. The trick to this is just to make sure that you put the numerator in parentheses and perform this operation before dividing by 14. Let me show you what I've seen many students do over the years. I've seen many students who get things wrong take 108 minus 100 divided by 14. Now, what is your calculator going to do if you enter it in that form? It's going to take the 100 divided by 14 first, and then whatever you get here, it's going to subtract it from 108. That's not what we need. What we need is we need to take 108 minus 100, make that operation, which we all know is 8, and then divide by 14. So to make that happen in your calculator correctly, that's wrong. And that is correct, okay? So same logic here. Substitute 95 in for x, 100 for mu, 14 for sigma. 95 minus 100 is -5 divided by 14 is -0.36. Now let's pump the brakes just a little bit and take a look at what happened. In z-scores, z-scores can be positive or they can be negative. If the x value is bigger than the mean, our z-score will be positive. If our x value is less than the mean, then our z-score will be negative. So we're going to study this a lot more later, but what this tells me is that the 95 is 0.36 standard deviations below the mean. This tells me that 108 is 0.57 standard deviations above the mean. Now, once we get into sampling distributions, our z-scores get a little messier, but with a little bit of organization, it's not much more challenging than up here. So still, I'm going to put parentheses around after I make the substitution, putting 14.2 in for x bar and 15 in for mu. I'm going to put the parentheses around there as a mental note to me that I need to make this operation before I do anything down here. And I'm also going to put this in parentheses because this has to be done separately. The 2.5 divided by the square root of 68 after I make these substitutions into the part in the denominator. So the top part's easy. 14.2 minus 15 is negative 0.8. Probably can do that one in your head. If not, just grab your calculator. And then we need to divide by this quantity. Now, what I see students do sometimes is they get sloppy here. And they put negative 0.8 divided by 2.5 divided by the square root. What is the square root of 68? This is wrong, because what it's going to do is it's going to read from left to right, and it's going to take negative 0.8 divided by 2.5, make that calculation, and then divide by the square root of 68. That's not what we want. We don't want that answer because it's incorrect. We want to take negative 0.8 divided by the quantity of 2.5 divided by the square root of 68. Okay? And in this case, the calculator is going to perform this calculation first, then it's going to take negative 0.8 divided by whatever that is calculated to be. So in this case, we get the correct answer rounded to negative 2.64. Now the interpretation of this would be very similar to the interpretation up here, in that we would say that a sample mean of 14.2 is 2.64 standard errors. This is actually called the standard error, not the standard deviation. Trust me, I'm going to teach you that later once we get into the stats part of this class. But negative 2.64 standard errors below the mean of 15. Let's say that again. The sample mean of 14.2 is 2.64 standard errors below, because it's negative, a mean of 15, a population mean of 15 actually. Now if this number was above 15, this would be a positive number because our difference up here would be positive. Then we would just say that this sample mean is whatever standard errors it is above, because this would be positive. But again, if that's a little fuzzy to you, don't worry about it. Once we get into the stat part, I'll teach that very thoroughly. All right, gang, all I got.